one of the driest places on Earth flooded for the first time in half a century. The Sahara Desert, a sea of sand larger than the entire United States, now has lakes where there were only dunes. How is this even possible? When the desert was bone dry for decades, how did water suddenly appear in places no one would have thought? We've all heard of the Sahara. It's the largest hot desert on the planet, covering an area so vast you could fit 100,000 Disney World theme parks inside it. In September 2024, something unprecedented occurred. More than a year's worth of rain fell in just 48 hours, transforming golden dunes into shimmering lakes and reviving a dry lake bed that hadn't seen water in over 50 years. An extratropical cyclone formed far over the Atlantic Ocean and pushed deep into the desert. This cyclone drew moisture from equatorial Africa in a highly unusual pattern, creating a perfect storm of conditions that meteorologists are still trying to fully understand. In just 48 hours, the Sahara received more rain than it typically sees in an entire year. For a place to be considered a desert, it has to receive less than 4 inches of rain per year. The Sahara's average annual rainfall is just 3 inches. Compare that to the nearly 45 inches a year in New York, and you start to understand just how dry this place normally is. Satellite images from NASA revealed something. Large patches of water appeared across the typically barren landscape. The desert town of Muga, known for its towering sand dunes, suddenly featured lakes reflecting palm trees and casting surreal images across the sand. This lake bed had been completely dry for over 50 years. 50 years. That's longer than most of us have been alive. And suddenly, water returned. The lake filled up, creating a body of water where there had been nothing but cracked earth and sand for half a century. This unusual event has yielded a large trove of observations, giving researchers a clearer look at how the atmosphere is changing as the planet warms due to climate change. Meteorologists are reviewing the weather setup and factors that made it possible. The downpour, which shattered prior records, points to a broader rise in atmospheric volatility tied to higher temperatures and extra moisture in the air. Initial readings from weather stations indicate that episodes like this could happen more often, pushing scientists to revise long-held views of the Sahara's climate. A region once labeled among the driest and most stable on Earth may now face the same kinds of extreme swings and sudden storms increasingly seen in many other places. Did this information surprise you as much as it did me? Share your thoughts in the comments below. Now here's where this story takes an incredible turn into the past. Because the Sahara wasn't always a desert. In fact, up until about 6,000 years ago, the Sahara was grassland. People lived there and farmed the land. Northern Africa was once covered in green. Rainfall was plentiful, filling lakes and rivers, creating rich pastures and even forests. The Sahara of that time looked nothing like the dry and empty land we see today. Then the climate began to change. The region dried up, and the plants slowly disappeared. Without roots to hold the soil together, the wind took over, carrying away the fine particles. After a few thousand years, the Sahara turned into what we recognize now, a vast stretch of sand and stone that seems to go on forever. But surprisingly, sand makes up only about 1/4 of the Sahara. Those golden dunes are just one part of the desert's landscape. The rest is made up of gravel plains, salt flats and rocky plateaus. This makes us question whether we fully understand what the word desert really means. For scientists who study the Earth, geologists, a desert is defined by one key feature: the amount of rainfall it receives. If an area gets very little or almost no rain, it is called a desert. The Sahara clearly meets that definition, with an average yearly rainfall of only about 3 inches. By comparison, New York City receives around 45 inches each year. When we look at rainfall, the Sahara is actually only the third largest desert in the world. The two biggest are Antarctica and the Arctic. They are larger by millions of square miles. Those two are known as polar deserts, while the Sahara is called a subtropical desert. In contrast, the highest temperature ever recorded in the Sahara is a scorching 136, but it is not always burning hot there. When the sun goes down, the desert cools quickly, with nighttime temperatures close to what Denmark experiences on average each year. This constant swing between hot and cold makes traveling in the Sahara quite a challenge. Now, how deep is all that sand? It varies between about 70 and 140 feet. That's not as deep as many imagine. If you place the Statue of Liberty in one of the tallest dunes, half of it would still be visible above the sand. These great sand layers were shaped over time by the wind. The term for this is aeolian, a word that comes from Greek and means wind. In dry regions with little vegetation, the wind erodes the surface faster. which is exactly what happened across North Africa. Beneath the sand lies bedrock and cracked clay. If you were to dig deep, you would find the same kind of base as almost anywhere on Earth, except for one difference. In most places, a layer of soil covers the bedrock. In the Sahara, however, the dry air and lack of plants prevent soil from forming, so sand remains on top. Over thousands of years, many fascinating things have been discovered beneath the desert sands. One example is the petrified tree trunks, fossilized remains of ancient forests that once grew when the Sahara was still green and full of life. Some of these preserved trees reach heights of 65 feet, and their wood still shows its original texture and knots. In some areas, even fossilized pine cones have been found, silent witnesses of the Sahara's long-lost greenery. If you found this video helpful, don't forget to hit like, subscribe, and turn on the notification bell so you won't miss our upcoming journeys. Tap the like button to let us know this content is making a difference. And if you're watching on your phone, be sure to press the hype button right below. Every hype helps this video get published to more people, and it truly supports me in earning extra income. I promise to keep bringing you even more great content. Let me tell you about one of the most incredible archaeological discoveries ever made in the desert. For centuries, there was an entire city hidden under the sand. Its name was Timgad, and it was a Roman outpost constructed by the Emperor Trajan around the year 100 in the current era. Timgad was a thriving city during the time when North Africa was still relatively green. For various reasons, its residents abandoned it around the year 700. The sands of the Sahara soon engulfed the entire city. It remained hidden for nearly 1,000 years, buried under countless tons of sand, waiting to be rediscovered. Then, in the 1700s, a Scottish explorer started digging in the area. His team first uncovered a sandstone triumphal arch, 40 feet high, similar to the ones we can see in Rome and Paris today. Can you imagine the moment when that arch first emerged from the sand? An amphitheater soon popped out of the sand, followed by well-preserved statues of Roman emperors. The Scotsman's find was so impressive that no one believed him at first. People thought he was making it up or exaggerating what he had found. It took 2 more centuries for archaeologists to fully excavate the city during the 1950s. What they uncovered was breathtaking. The site covers a surface as large as 10 polo fields. The ruins reveal the full mastery of Roman city planning. All the streets meet at a right angle in what is known as an orthogonal grid. You can find the same layouts in modern cities, such as New York. The Romans were incredibly advanced in their urban planning, and Timgad is a perfect example of their engineering prowess. Historians believe that at its peak, around 10,000 people lived in Timgad. The city was home to a mix of cultures, including Romans and people of African origin. Today, over 2.5 million people live in and around the Sahara Desert. These communities are spread across 11 countries, and the desert itself continues to expand. It is now about 10% larger than it was 100 years ago. This growth is not caused by sand spilling outward, but by gradual changes in nearby ecosystems. As wind erodes the soil and plant life disappears, the land slowly transforms into desert terrain. To combat this, several African nations have united to create a project known as the Great Green Wall. Its main purpose is to slow down desertification in the Sahel region and stop the Sahara from advancing further. The plan is bold and forward-looking, aiming to plant a massive stretch of trees that will run from the western edge of Africa all the way to the east. This forest will not only be long, but also wide, forming a living barrier against the spreading desert. If you are not familiar, the Sahara Desert is located in northern Africa, stretching from the Atlantic Ocean all the way to the Red Sea. It covers a massive area, large enough to fit around 100,000 Disney World theme parks side by side. Scientists have found that its borders are slowly growing. Deserts often appear in the subtropical regions because of a phenomenon known as Hadley circulation. This happens when warm air rises at the equator and sinks again in the subtropics. This movement of air causes dryness, which leads to the creation of desert regions. Since the 1920s, researchers have observed that the Sahara has expanded by more than 10%. So how is this happening? To understand that, we need to go back to the beginning. The Sahara Desert is known as one of the harshest environments on Earth today. For a region to be officially classified as a desert, it must receive less than 4 inches of rain in a year. Because of such limited rainfall, deserts are dry, with almost no moisture in the air. During the day, temperatures can soar to 130. With so little water, it is hard for most plants and animals to survive there. However, the Sahara has not always been this barren. It may be hard to picture northern Africa without endless sand dunes, but around 20,000 years ago, the Sahara was actually a vast green oasis. Recent scientific findings support the idea of what is now called the Green Sahara. Back in the mid-1800s, a German explorer traveling across the desert discovered ancient paintings and carvings created by nomadic artists. What he found was astonishing. The artwork did not show endless sand or camels. Instead, it showed scenes of wild animals like giraffes and hippos, along with herds of cattle and sheep grazing. Such images seem impossible in today's Sahara. Artists usually paint what they observe around them, so this discovery deeply surprised the explorer. The drawings were so detailed that it was clear the artists had seen those animals up close in their daily lives. This ancient rock art can be found across the northern part of Africa, stretching from western Sahara all the way to Saudi Arabia. Geologists became very interested in these discoveries and began studying them for clues about the region's past. Their research confirmed that northern Africa was once much wetter than it is now. Evidence from deep-sea sediments off the coast of Mauritania supports this idea. By examining samples of underwater sand and mud, known as Saharan dust flux, scientists determined that a lush green Sahara once existed. When more dust blows into the ocean, it means the region is dry. During the wet period, sediment cores showed that the amount of dust from northern Africa was only about half of what it is today. This humid period is linked to natural cycles of the Earth. Normally, our planet tilts at an angle of 23.5 degrees, but this tilt slowly changes over time. The tilt determines how much sunlight each hemisphere receives, influencing the planet's climate and ecosystems. During the Green Sahara period, Earth received about 4 to 8% more sunlight than it does now. Around 20,000 years ago, the northern hemisphere tilted in a way that caused it to get more direct sunlight, increasing warmth and humidity in the area. As the northern hemisphere became warmer, it affected monsoon patterns, especially the West African monsoon. Monsoons are wind systems that control rainfall and humidity in different regions. When the air gets hotter, it rises, pulling in moist air and creating more rainfall. Gradually, northern Africa became much wetter. The higher moisture levels created lakes and rivers across the Sahara. Vegetation began to grow, and the plants helped the soil hold onto water. There is evidence of natural basins and massive lakes across the region, some large enough to hold all of North America's Great Lakes combined. Archaeologists have also found signs of thriving communities in areas that are now dry desert. These discoveries suggest that ancient peoples made full use of the humid period. Researchers believe that human populations reached their peak in the Sahara about 9,000 years ago. Evidence includes fireplaces, hunting tools, fish hooks, and even piles of fish bones. Studies show that there have been more than 230 green periods over the past 8 million years. The amount of solar radiation constantly changes due to Earth's natural orbital cycles. Because of this, another Green Sahara period will almost certainly occur again someday. It may take thousands of years, but it will happen. Just as the Sahara once turned green, it will eventually turn yellow again when the planet's tilt shifts and the climate adjusts. However, scientists are now focusing on another major phenomenon. It is known as desertification, which means the process of fertile land turning into desert. The Sahara Desert is currently spreading into the semi-arid region of the Sahel. In 1950, this area supported around 31 million people, but today its population has grown to more than 100 million. This rapid increase in population has played a big role in the Sahara's expansion. Many people who once lived as nomads have settled down to farm, and the land is being used more heavily. This has weakened the soil and reduced its ability to recover. The growing demand for food has led to overgrazing and overfarming, causing even more land to turn into desert. Research also shows that natural climate cycles influence rainfall patterns in both the Sahara and the Sahel. Scientists note that deserts are not fixed in size. They expand during dry seasons like winter and shrink when the weather becomes wetter, usually in summer. To the south of the Sahara lies the Chad Basin, a large body of water that helps scientists monitor the desert's growth. This basin sits in the area where the Sahara is pushing southward. A climate expert from the University of Maryland explains that rainfall in this region has dropped significantly. Because of the lower rainfall, there is now less water throughout the basin, and even Lake Chad itself is shrinking. One of the most remarkable effects of the recent flooding is the dramatic change in the landscape. The desert town of Muga, once famous for its vast sand dunes, now has lakes where there used to be only endless stretches of sand. The water reflects the palm trees and creates stunning, almost dreamlike scenes that have temporarily reshaped the desert's appearance. The most impressive example is Lake Erie, a dry lake bed located in Morocco's largest national park, which has come back to life after being dry for more than 50 years. NASA satellite images have captured large areas of water scattered across what is normally a lifeless desert, clearly showing the scale of this transformation. Up new possibilities for environmental research, it has also caused severe destruction in several areas. Morocco has suffered the most, with more than 18 people losing their lives, and major damage to infrastructure. Roads have been destroyed, power lines have gone down, and many villages have lost access to clean drinking water. Some of these communities were still recovering from last year's earthquake, and the floods have made their situation even more difficult. For the people living in these regions, the floods have brought both hardship and opportunity. Traditional desert farming has been disrupted by the sudden arrival of so much water, but some farmers are now considering how to use this temporary supply to improve their crops in an area that usually struggles with drought. The unexpected presence of water has encouraged many to rethink their farming methods. At the same time, the floods have revealed serious weaknesses in the region's infrastructure, highlighting the urgent need to strengthen preparations for future extreme weather events. The unprecedented nature of this flooding has fueled discussions among scientists about the long-term effects of climate change on desert regions. According to climate researchers, this event is part of a broader trend of increasingly unpredictable weather patterns that we need to understand if we're going to prepare for what's coming. Here's the fundamental science. As global temperatures rise, the atmosphere's capacity to hold moisture increases. It's basic physics. For every degree Celsius of warming, the atmosphere can hold approximately 7% more water vapor. The problem is that this moisture doesn't distribute evenly. Instead of gentle, regular rainfall that ecosystems can absorb and utilize, we're seeing the moisture concentrate and then release in massive, destructive events. Climate models predict that as global temperatures continue to rise, the likelihood of similar storms forming over the Sahara will increase. Long-term projections indicate that the Sahara may experience more frequent and intense weather events over the coming decades. This is prompting the need for better planning and adaptation strategies in desert regions worldwide. But here's the challenge. But there's another layer to this story that we need to consider. Every year, millions of tons of Saharan dust are blown across the Atlantic Ocean. This dust fertilizes the Amazon rainforest, providing essential nutrients that the rainforest needs to thrive. It also affects hurricane formation in the Atlantic. Saharan dust can suppress hurricane development by creating dry, stable air masses. If the Sahara's climate continues to change, the Amazon could receive less fertilization. Hurricane patterns in the Atlantic could shift. These are global consequences of regional changes. Although this flooding event has captured global attention, it is not without historical roots. The Sahara was once a much wetter region, often called the Green Sahara, where lakes and grasslands supported thriving human communities about 11,000 years ago. This dramatic change in the landscape offers a powerful reminder of how quickly the environment can shift under the right conditions. Today, scientists are studying ancient records and geological evidence to better understand how the Sahara might continue to evolve under modern climate influences. The data collected from this flood will play a key role in improving climate models and predicting the future of desert ecosystems. Researchers are especially focused on whether this event signals a larger climatic trend, or if it is simply a rare occurrence in an otherwise dry region. The possibility that the Sahara could face more frequent extreme weather has sparked global discussion on how to prepare for such changes. For the communities living in these tough desert conditions, learning to adapt to both long droughts and sudden floods will be essential for survival in the years ahead. The Sahara's story is ultimately our story. It's a story about change, adaptation, resilience, and the interconnectedness of all life on this planet. What happens in the desert doesn't stay in the desert. It ripples out across the entire world, affecting weather patterns, ecosystems, and human communities thousands of miles away. The question isn't whether the Sahara will continue to change. It will. The question is whether we'll learn from these changes and take the actions necessary to create a more stable, sustainable future for everyone. Because in the end, we're all living in the same desert, under the same sky, sharing the same uncertain future. And what we do today will determine what kind of planet we leave for the generations who come after us. Now I want to hear from you. Were you as shocked as I was to learn about the Sahara flooding? What surprised you most in this video? Was it the history of the Green Sahara, the expansion of the desert, or the implications for our future? Share your thoughts in the comments below. I read every single comment, and I love having these conversations with you. And if you found this deep dive valuable, make sure you're subscribed to the channel. Next week I'm exploring another shocking climate event that's rewriting what we thought we knew about our planet. You won't want to miss it. Hit that subscribe button and turn on notifications so you don't miss out. Thanks for watching, and I'll see you in the next one.
Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.